Mm, Can you hear me? When I was testing my microphone trying to join the workshop, it wouldn't play back my sound to me. So I don't know if that's my mic. Perfect. Cool. Let me get started on sharing my screen. Perfect. Okay, hello everyone, and welcome to today's workshop. Today's workshop is all about Kubernetes network policy management using Calico Open Source 3.30. So I will start by saying that the workshop is available on GitHub, and you've got a couple of participation options. You can watch along kind of webinar style. I'll be going through the workshop sort of step by step, showing you what I'm doing, talking through it. If you want to follow along with your own cluster, I do recommend you getting that set up now. So there should be a docs tab that says like Calico Open Source 3.30 Kubernetes. It's the name of the workshop, basically, the third one down, and that will take you to this. So if you do need to get your cluster up and running with Calico 3.30, a little bit more recent, I recommend checking this out immediately, or the Calico Quick Start Guide, and just getting your cluster up and running while I'm sort of talking through the introduction stuff. So I've already got my cluster running. I'm just using Kind on my laptop, nothing fancy, just for this workshop. And if you don't have a cluster ready to go or can spin one up quickly, you're welcome just to follow along. You've got a link to the GitHub as well, so you can always sort of do this afterwards, watch along today, and you've still got access to the instructions. So that's the first thing. There will be a recording. This is being recorded. That will get sent out at some point afterwards. If you have any questions as we're going through today, I do have multiple monitors, so I can have the sort of chat box up on my other screen. So if you have questions, feel free to pop them in there, and then I'll try and answer them as we go through or at the end. Yeah, useful links, you can find these in the docs tab, including today's workshop and the Calico Quick Start Guide. And might run a few polls, and there will be a survey at the end, so your participation in those is very much appreciated. And this is a brand new workshop for today, because Calico 3.30 and Whisker and everything like that is fairly new. So any feedback that you can share is useful, basically. So let me check. So before we get started, let me just run a quick poll to start with. So how would you describe your sort of expertise coming into today's workshop with sort of Calico networking and security policies? So there should be a polls tab next to your chat box. If you want to go in and vote on there, we can kind of see what we've got today. If we've got a lot more sort of novice beginners, I can spend a little bit more time talking about a bit more about network policies, sort of how they're built. If you're more intermediate advanced, we can kind of assume that you've built policies before and you kind of know what's going on. So I'll leave that open for it. Looks like we've got a bit of a spread from novice to intermediate at the moment, which is okay. So last few seconds. Okay, so no one is advanced, which I guess you probably expect. So I'll start with a little bit of an introduction to Calico. So sort of as you may already know, Calico is sort of supported on multiple different data planes. So we've got IP tables, NF tables, eBPF windows. So it can be really easy to sort of swap Calico to change the data plane and versions depending on your needs. Let me. It also supports different workload types. So today, everything that we'll be doing will be in containers, but we also support VMs in bare metal as well, so you can sort of write your security policies, and they will also apply to the VMs, bare metal, and containers, so keeping your environment secure, kind of whatever workload type that you have. And so leading on from that, lots of different environments too. So typically when we do these workshops before, they were typically on the cloud, so we'd be doing them on EKS, AKS, but Calico runs on the cloud, on premises, at the edge. And you can see at the bottom all of this that Calico supports. So no matter where your sort of containers, workloads, VMs, etc., are running, or what distribution that you're using, Calico will sort of give you a consistent experience across those different environments. And a little bit of an overview of the Calico platform. So a lot of these features will be in our commercial offerings. So we've got Calico Enterprise and Calico Cloud. But today I've highlighted some of the features that we're going to be working with open source. So obviously we're going to be using Calico as the CNI today, although that's not going to be the sort of focal point of the workshop. But Calico gives you sort of functionality for your network security, your network threat detection, observability, incident response, as well as CI/CD automation and tools. So all within sort of one product with Calico, you get access to all of this functionality. And then with the open source today, some of these features have moved into open source recently in the latest release in 3.30. So network policies has kind of been there for a very long time. Network sets as well. We'll have a brief look at network sets and create one, but using the IP or CIDR ranges as the DNS policies and sort of adding DNS names into network sets is a commercial feature. We'll be staging our preview, test them before deployment. So you can just double check whether Calico is sort of capturing that traffic against a policy, even if it's not actively enforcing it or altering the flows at that moment until it's enforced. And then we'll have a look at policy tiers as a way to help with your network policy organization, as well as setting precedents or adding isolation between teams. The dynamic service graph we'll have a look at as part of the Calico Cloud free tier at the end of the workshop today. And then the policy board, same thing, as well as some of the policy tools and namespace isolation. So hopefully by the end of today, you'll not only have seen Calico Whisker and sort of how you can use that information that Whisker is collecting to help build your network policies and test them. We'll also have a quick look at the Calico Cloud free tier, which is sort of a free offering for one cluster. You get 24 hours worth of log data to just enhance some of that sort of observability and sort of policy tools to speed things up. So with that, let me swap to the actual workshop. Let me just reshare my screen. Okay, so I've got, because this cluster is running so locally, I've got my terminal window on the side of the screen here next to the workshop, so I can actually see what we're doing and copy any commands over. Just get a check, is the sort of terminal window readable, or should I make it a little bit bigger? If it's a bit hard to read, I can make it bigger, that's no problem. So if it's too small for anyone, just let me know in the chat. So for today, this workshop, we'll be mainly working with sort of Calico Open Source, Calico Whisker, and then we'll have a look at the Calico Cloud free tier at the end of the workshop. But I guess why you're here, why you probably care about network policies, is that sort of the traditional approach to securing sort of VMs, etc., if you're using IP addresses, doesn't really translate or work with Kubernetes. So dynamic pod IPs, ephemeral, always changing, especially if you're scaling things up and down. Bear with me. And okay, hopefully, yeah, my mic's still working. Normally I have my dog in the back of the room, so I like the tools that kind of block out his snoring, but he's not in the room with me today, so that's good. So yeah, you need a more Kubernetes native approach to the networking security for your clusters. So that's where the network policies come in. They sort of target workloads by using the labels and sort of selectors that you're familiar with in Kubernetes, as well as being able to sort of write a variety of ingress rules, egress rules. They're also using those selectors. So as your workloads potentially scale up and down, or you sort of remove deployments, bring them back again, if the labels are staying the same, the network policies and your network security stays in place as it scales. So it's a much more appropriate solution for Kubernetes, especially if you're wanting to secure within your cluster. A lot of organizations, especially larger organizations, will sort of maximize, I guess, their resource usage. So they'll tend to stick with really large clusters, have lots of different teams, applications running in those clusters, and then they need network policies to help keep them isolated, compared to an approach that some people might take where they have one cluster for everything. If you're using really big clusters, or if you've got multiple sort of tenants, applications running in there, network policies will help keep them isolated within the cluster. So as I mentioned, this assumes that you have a sort of Calico open source cluster already running. If you want to follow along with this, I already do. So hopefully if you were setting that up, it's already set up, or it's close to being done. And then so we'll start off just by getting familiar with Whisker and sort of checking that out. So what you need for this is to make sure that you're running Calico Open Source version 3.30 or greater. And then now by default, Calico Whisker is getting installed and deployed automatically in the 3.30 greater clusters. But it's not accessible from outside the cluster by default. So we need to allow access to do that. So what we'll be doing is just setting up some port forwarding and then opening up the Whisker web console, which I'll do, to sort of have a look at those network traffic logs in real time. So see, I don't know how to change my speaker. Otherwise that's going to keep coming up the whole time. Okay. So just to verify that I do have Calico 3.30 running here, I'll just run the sort of get info command, move this out of the way so we can see the result of that. So we can see here what we're looking for is the Calico version in the spec. So I'm running 3.302. And we can also check that Whisker is running, again, just by copying and pasting these commands. So we can see that we've got this running. We've got 2 pods up and running for Whisker. And we can also check that we've got the Whisker service here, as we'll need to know what ports to forward it to. So we can see that Whisker is running on 8081 down here. So when we're doing our port forwarding, we're basically just sort of saying this service, we're going to redirect it to 8081, keep that port in our browser. And then if I can open a new tab, I guess it's going to be a different color scheme every time. And just run that command in here. And the reason I opened a new tab is just because I want to keep Whisker forwarding all the time. So I need to leave that process running. And then I'll come back to this tab and kind of do most of the things in here. So yeah, let me copy the link here. So I just put the link again in the chat. And this takes you straight to module 1 basically, but there should also be a link in the docs tab next to the chat window as well for the workshop. I think it's the 3rd link down. So if you want to follow along either in GitHub or yourself, you've got the link in the chat. So I'm going to keep this terminal window open. That's just in my other tab there. And then if we go to our sort of localhost 8081, we should be able to see the Calico Whisker UI. Okay. And those mainly just Calico stuff at the moment, or just sort of in-cluster stuff, because I haven't actually installed any applications in here yet. And so I guess for the question at the moment in the chat, so Whisker is running automatically. You can kind of see that's running there. I haven't personally checked to see whether or like how you would sort of stop Whisker running. I imagine that you could, but off the top of my head, I don't. I haven't looked through the docs to try and get the answer to that either. So that might be something I can follow up with afterwards just to see if you can install Calico without Whisker. Or it might be, we've got sort of a lot of documentation on installing it, so it might be in here somewhere. So now that we can see the Calico Whisker UI, I'll just give you a quick rundown of sort of what's going on in here. So basically Calico is collecting flow logs for every single communications or traffic flow that's going on inside your cluster, which you can see here. Whisker will then refresh every few seconds just to show you the latest flow logs. And then it kind of gives you a sort of overview of where the traffic is going from. So you've got the source namespace, you've got the source name, where it's going to. So again, you've got destination namespace, destination name. You've got the protocol, you've got the port, when that traffic flow was. And you can expand any of these sort of flow logs and it will give you a little bit more information. So you can read just for this one, the sort of time, where it's going from, where it's going to, what the action was, so if Calico was allowing or denying that traffic based on sort of the policies that you've potentially written inside your cluster. You can also see the source and destination labels. So as I mentioned for the sort of Kubernetes network policies or Calico network policies, when you're writing these policies and creating your rules, you're probably using ports, protocols, and you'll be using these labels as a way to select sort of what the policy is applying to, as well as the ingress and egress rules. So basically everything that you need to know to sort of get started with writing your network policies, you can find in Whisker through these flow logs. And then once you've sort of applied policies or you're testing them or you've got staged policies in place, the Whisker will also tell you what policies apply to that traffic. So you can see at the moment the sort of enforced policies, there's not many, just one for sort of Kubernetes. If you see the KNS is kind of like Kubernetes default one. So that's just going to storage, I guess, and allowing that. Any pending policies will be sort of staged policies that aren't yet enforcing any traffic, or maybe policies that have been applied, but there's still sort of active connections in place. So once those connections are broken, the policy will then apply to that network traffic. So that's why you kind of have two lists, one for enforced, one for pending. And then once you sort of close that, it will start going again and returning back the sort of flow logs. And you can add filtering in here as well. So if you want to find and filter by a specific policy, source namespace or name, destination namespace or name, or port, just to help you narrow down if you're looking for specific traffic. Maybe you've applied, put an application inside your cluster. You know it's in a specific namespace and you just want to monitor that traffic so you can start to build network policies. The filtering will just clean up this view, make it easier for you to find what you're looking for. And there is also a tab here for denied flows. So at the moment we don't have any denied flows, but if we did, you would basically just see all of those ones listed here. Because especially if you're sort of building network policies, you're still kind of testing them out, and they are starting to deny flows, it makes it a lot easier to just sort of narrow that down, go in here and then correct your network policies, and then hopefully the number of denied flows in here, there stops being any more denied flows and it will go back to all flows, and then you'll see the allowed traffic here. So that's a quick introduction to Whisker, I guess, before we actually sort of use it. So now instead of just the sort of default behavior from what's running inside our cluster at the moment, we'll just generate some traffic and then sort of see those flows appear inside Whisker. So we'll be doing this by deploying an Nginx server, exposing it as a service in the cluster, and then we can test making HTTP requests from it from another pod that we'll just sort of spin up in here. Both of them inside that quick start namespace. So again, if you're following along yourself, pretty easy, you can just copy and paste the terminal window. So it should be creating our namespace. Nope, that's not what I wanted. Let's go back, copying this one. So this is just creating that sort of Nginx deployment now that's been created. And we want to expose that to make it accessible within the cluster. So let's expose that on port 80. And then now that should be up and running, we'll create our sort of BusyBox pod. I'll use using the BusyBox image, and we'll call the pod access within the same namespace that we'll use to make calls to the Nginx server that we just deployed inside this cluster. So because this has got the sort of bin sh, this is opening a shell into that access BusyBox container. And then from inside there, we'll just run these sort of wget commands against our Nginx server. And then what we should see, if that's all working correctly, is that HTML being returned should pretty much match this, just a welcome to Nginx page. So we can see here that the BusyBox pod is able to access the Nginx server. And I guess that's a good sort of reminder that sort of with Kubernetes, when you start a cluster, if you don't have any network policies in place, Kubernetes by default has sort of an allow all communication model. So everything is allowed to communicate with everything else, unless you start to put network policies in place. So if I had a network policy in place that allowed BusyBox to talk to something else, but not Nginx, because I hadn't allowed it to talk to Nginx sort of explicitly, that communication would get blocked. But until I sort of added any network policies into the cluster, everything is allowed to communicate with everything else. And we can also run some communication tests just to public internet, just to check that that's working. I guess that's some kind of bare. So yeah, we can access public internet. We're able to access Nginx. And then if we go back to Whisker, our source namespace quick start, the access pod is going out to access and communicate with different things. So let me, now I've got Whisker open. Let's run some of these. And I can filter my source for the access pod. Yeah, we can see the one out going to the public network. So that would be this one returning the sort of pandery bear thing. We've got the communications going to Nginx as well. So if we open this, we can see that we sort of exposed Nginx on port 80 back here. So we can see that when it's communicating with Nginx, we can see that that's getting reported here, that destination port 80 over the TCP protocol. And then so when I minimize that, it should go back to just refreshing the flow logs. So now we've had a quick look at Whisker, kind of tested some communication and watched those flow logs sort of appear pretty much immediately. I'll give you an introduction to policy tiers. So let me just exit out of that. So policy tiers allow enforcement of sort of higher precedence policies that cannot be circumvented by other teams. Policy tiers are evaluated based on order, as are policies within each tier. So typically policies are evaluated from left to right if you're looking at them visually, and then within each tier they're evaluated top to bottom. So this is a screenshot here of Calico Cloud, just so you can kind of visualize what we're talking about when we talk about policy tiers. This is a view that you do get access to in the Calico Cloud free tier as well, but not in Whisker. So with Whisker, you'd still be sort of creating, evaluating, looking at your tiers by the command line and doing it that way. But when you're building a tier, you would sort of give it an order that would determine which tiers get evaluated first with your network policies. And then when you create a network policy, you would specify which tier you want that network policy to belong to. And then within that tier, that network policy will also have an order. So a lot of organizations that are using Calico will have a security tier. And then these will be used for sort of generic, not necessarily generic, but like organizational wide security controls. And then the platform tier will typically have sort of infrastructure or platform related controls or policies that they need. And then developers or applications would have tiers that come afterwards. So you can see the app pets tier here. So then they can't write any network policies that sort of go against any of the rules that have been written in any of the tiers that have a higher order. And then we typically leave the default tier to go last. So we can check what tiers already exist within our cluster. Like that. So we can see that we have a few tiers already. We have the default tier, which is always going to be there. And then we've got admin network policy and baseline admin network policy as tiers. So there's a little note on those here. I believe these were introduced around sort of towards the end of last year, or a little bit before that. Admin network policies, baseline admin network policies. So this kind of gives you tiers in Kubernetes now. So you could write kind of like the security in the platform tiers. If you didn't create any new tiers for Calico, you could use the admin network policy tier to kind of put those in. And then any sort of like final network policies that you want, maybe as insurance, kind of like a default deny, you could put in the baseline admin network policy tier, and then most of your other policies in default. But we found most of our customers kind of don't use those as much, and they probably just create their own tiers and organize it their own way instead of trying to fit things into those 3 tiers. And so I guess for the question in the chat, if your appliance or application, I guess, is connecting to host or IPs outside of it, will Whisker list these connections? It will show them, like when I was going out to the public network, it kind of shows it as public network and anything in there. I'd have to double check in Calico Cloud free tier whether it does give you that information, but for Calico Commercial with Calico Cloud or Calico Enterprise, it definitely does. And then you can specify domain names inside your network sets and kind of group it, and you'll see it there. But what you can do is with the network sets, which we'll touch on towards the end of the workshop, is if you create a network set that has a specific IP address, if you know the IP address of where you're communicating to outside of your cluster, then it will show up like it says public network there. It would show up as the name of your network set. So that way you can kind of give meaningful identities to traffic that is leaving your cluster, and then it would make more sense. So the public network, you would see whatever the name of this would be, like Panda Face or something. And then I would know that it's not potentially just going off anywhere. I could quickly scan that and be like, oh, okay, I know what that is. That's fine. So let me check. I didn't skip any steps. There we go. We've got the tiers. Let's describe the default tier. So we can see here, this is the sort of tier definition, how you'd want to sort of define this. No namespace associated with the tier. We've got the tier name, kind tier, and I guess the sort of more important things here are in the spec. So we can see that we've got the order of the tier. So that would say where it comes. The order will be higher than what the admin network policy order is, but probably lower than the baseline admin network policy order, so it fits in the middle. And we've also got a default action here, which is deny. So if network traffic sort of is being evaluated by the default tier and it gets to the bottom, doesn't match any policies, the default action of that traffic would be to deny it. But you might see some tiers in there. You can set that to pass or allow, etc. So you get to choose what happens to the traffic once it gets to the bottom of a tier. And again, we can also describe the other tiers. So baseline admin network policy. There we go. So we could see for the default tier, the order was 1 million. And for the baseline admin network policy, the order is 10 million. So then you can see we've got lots of room in there to sort of build other tiers with different orders. And you can see the bottom of this tier would just pass the traffic on to the next tier. And then I imagine that will be the same with the admin network policy. Yes, you can see the order here is 1,000, pretty low. And the default action again is pass. So if you're building more tiers and it gets to the bottom of this tier and there was nothing in it, it's just going to pass it on to the next one. So if you're following along here, hopefully you've cloned the repo. There are some sort of manifests inside there. So now this is where I actually have to go and find where I kept this. Perfect. So inside the manifests folder is a YAML file with some tiers. So just sort of having a look at that, you can see those here. We're going to be creating a few tiers. We're going to be building a security tier, platform tier, and an application tier. So we're going to be deploying an application called Catfax shortly, and then any policies that we build will belong in that application tier. And you can see that I've put the order of that tier to make sure it's below the platform and the security tier, which are also then following behind the admin network policy tier. So let's create those. I can go back in and add the copy button when I update this workshop after. There we go. So we can see our 3 tiers have been created. So now if we do our kubectl get tiers, we can see that those 3 extra tiers have now appeared here in our list. And then so just a little graphic here to kind of explain what people typically do with a security tier, platform tier, application tiers, and the default tiers, etc. So that's what we commonly find is sort of a theme before everyone using Calico, is that they probably have multiple application tiers for each application that they're running, and then they'll stick with one security, one platform tier at the beginning. And then some sort of best practices for tiered policies. As I mentioned, it sort of helps with security teams. They can help prevent unauthorized viewing or modification of the higher precedence tiers, also those with the lower order. Also allow to manage the policies in their workload. So they will typically be the people in the application tier, or depending on what application or thing they're responsible for. You can use RBAC, things like that, to limit access to the different tiers. So again, for a lot of our customers using tiers, you sort of have the people sort of managing the platform or the security team sort of have oversight of everything, and then they restrict who can have access to the application tiers and who can sort of build and add those policies in there. So now we've kind of set the groundwork. We know how to look in Whisker, how to find all the information from the flow logs that we're going to need to build our policies. We've built some tiers, so we have a place for our policies to live. And we can actually go on and start adding in some network policies to our cluster. So before we do that, we'll just deploy the Catfax application. So that should create a bunch of different pods, services, etc. down here. And we want these to all be running ideally. They're still creating. And then this kind of touches on what we've already looked at with Whisker. So before you can even write your network policies, you need to know information about the traffic flows in order to secure it. You need to know what labels the source and destination have. You need to know what ports they're traveling over, what protocol, etc. So that's all the information that we'll be able to get from Whisker once this application is up and running. And I guess this is very similar here to what we're looking at. So if you want the source labels here, so when you're building a network policy and you're choosing what you want it to apply to, that's probably where you'll use the source labels. And then if you know that it's communicating with, let's say, Nginx, for example, then you can go and write the destination labels. So if we were writing a policy for this BusyBox access pod, for example, in our policy, at the beginning of our policy, we would be sort of defining that it applies to anything with this source label. So if it lives in this quick start namespace, has the rent access label, or we use a selector for that. And then maybe add an egress rule that says, okay, you're allowed to go outside of this pod over port 80 TCP protocol, as long as the destination sort of label is app equals Nginx. So that means the access BusyBox pod would still be allowed to talk to Nginx, but if it tried to go out to the public internet, that wouldn't have been allowed because the public internet wouldn't have the sort of destination label as app equals Nginx. So there we go, all our Catfax pods are now running. So if we press play again, we should start to see some Catfax traffic appearing in here. So, oh, I guess I should turn off my filters, that might be why. So now we can see we've got the source namespace, the cat facts. I believe those pods are just generating traffic all the time, so we have things to look at in here. Source namespace, if I filter that by cat facts, you can see that we've got a worker pod, we've got a facts pod. They're all busy off communicating with this database pod. So Kubernetes, core DNS services as well. And if we go back to the terminal window, you can see that actually when I was getting the pods that tracks, we've got a database of facts and a worker pod. So all of their traffic flows are kind of showing up in here now. And if we're going from the worker pod to the database, again, we can go in and have a look in here for more details. We can see some source labels. So if we were writing this policy to sort of restrict or allow traffic from the worker pod to the database, but not anywhere else, we'd be able to use the source labels of app equals worker as a way to sort of target the policy on this pod. And then our egress rule would say it's okay to go and talk to anything with a sort of label app equals database over port 3306 in the TCP protocol. So we can quickly get all the information that we need there to start writing our policies. Now, just to speed things up, if I do a cat, which folder is this in? Manifest. Oh. What did I call it? Cat, facts, NWP. There we go. So here we can have a look. We've got a few network policies that are going to get applied to our cluster. So we've got one here. So when you're building a network policy similar to most resources in Kubernetes, you've got this sort of API version. So this will be Calico. We're using Calico network policies. It's a network policy. We're defining what the name of the policy is, and the prefix here, this is our tier. So we've always got the sort of tier name dot network policy name. So if you remember a few moments ago, we made the application cat facts tier. This is going to apply to resources in the cat facts namespace. This policy will live there. Again, we're defining which tier it belongs to, the order. So within the application cat facts tier, what order is this policy? And again, you can see we've got our selector here. So this policy will apply to any resources in that namespace that have app equals facts as the label. So that wasn't this one, but if I expand the row here where facts is going off to talk to something else, we can see that we've got that source label in here. So we would have used this information to help build our policy. And then you will define what type of rules you want your policy to have. So we've got both ingress and egress rules here, but you can just have one or the other. And then we've gone on to define each of these rules. So for our ingress rule here, we've got we're denying traffic coming into the facts pod here. I guess over the TCP protocol, doesn't really matter where it's coming from. And destination here is 80. So I guess if it's coming into the facts over port 80, that will get denied. But egress traffic from the facts is allowed if it's going to the database over port 3306. And then they all kind of follow the very similar layout. This one here for the worker pod only has egress rules, so we can see that it's going off to talk to the fact service. It's going out to sort of public internet. It's going outside of a port 443. That's okay. And again, it's going and talking to the database over 3306. And then similar for the database as well. The database is allowing incoming traffic from both the worker and the facts over port 306. So here we've kind of set up workload isolation, or we will be sort of micro-segmentation and adding network policies around every pod inside our application. And then we've just got a pass policy at the bottom of this tier. So if no traffic matches, hopefully it would match this one and then just get passed on to the next tier. So based on what we were having a look at in Whisker and having a look at the network policy, this matches the CatFacts application that we have. So we can see we've got the database here, traffic coming from the worker and the facts over 3306. The worker was talking to the facts in the database, which we saw in Whisker, as well as the facts service talking to the database. And then the worker We'll go out and in catfact.ninja as well. And then if people want to access the catfacts application from the port 80 into the facts service. So before applying the policies, let's just do another port forward here to sort of have a look at the application in our browser, have a look at some facts. So again, I'll just open a new tab here and just run that. And then this time we're doing from port 8080 to 80. So if I go to localhost 8080, you can see that you get a cat fact coming back here. So I think every time you refresh the page, it gives you a cat fact, although every cat fact has a picture of a dog. So you know the application's working, it's getting the connections in here, you're getting a new cat fact in there. So we go back to my original terminal. So we saw the facts. Now we can apply those policies. And we can see that those policies all got created. And now just to kind of kill the connection and make sure that the policies are working if we start the connection again, I'm just going to delete these pods because it's deployment, they should be starting right away. Although like name is different every time. Let's see, delete pods, cat facts. Delete the facts here. Did that delete? Oh, it's saying that it did delete. Okay, there we go. We can see that that original pod is terminating. We've got a new pod coming up now. So that probably killed our port forwarding, or it should, once that new pod is coming up, maybe not. So if we go back to localhost 8080, now, because we apply those network policies, and if you remember there's our facts policy here. The ingress rule here was actually action equals deny. So now we've applied those policies, I'm trying to access my fact service. It's no longer working. I can't reach that site anymore because the network policies are blocking it. And then so hopefully we'll be able to see that traffic in here as well. If I go back and press play, there we go. We can start to see some denied traffic appearing on here. So if I keep trying to refresh this, we should get the denied flows here and up here and see all of these flows here that are getting blocked into the facts service and the catfacts namespace. And then this is where we can go in and we can have a look at the enforced policies. We applied this, and we've got the action deny here from our application catfacts tier, and the name is facts. So this matches our policy that we created here. It's called facts. In that tier, ingress traffic is now being denied over port 80. And then we can very clearly see that as well in the policy information that's being returned inside Calico Whisker. So now let's go and edit our policy and just change that to allow, because we want the application to be able to access the fact service. So we'll just go and edit this, change the ingress rule from action deny to allow, and save that. We can see that policy was edited. Let's just run a describe command just to make sure that it now says allow. And we can see ingress now equals allow. So now we shouldn't see any more deny flow since we edited the policy. It should be allowed. Hopefully now if we refresh this, should come back. I guess hopefully we'll start to see some allowed traffic into the facts. Okay, here we go. So we've got the worker is now starting to talk to the facts again. We've got a lot more green. No more denied flows are now coming through on here. And it's able to talk to the fact service. So I guess very quickly being able to spot what the action is if you're getting denied traffic flows, seeing what policy is responsible for denying the traffic means that as you're sort of building network policies, you want to sort of test them, verify them, make sure they're working correctly. You can very quickly sort of visually find out, okay, this is denying traffic, and then go in and fix it and have a look at that policy. So from those sort of flow logs in here, we knew exactly which policy to target, to go and fix, do a quick edit. And then now we can immediately see that all of the actions are allowed. That policy is now allowing the traffic through. So we'll just add some more policies to our cluster. So this one is going to go in the platform tier, like I mentioned. So this kind of policy will be needed as we start building more policies, just to make sure that everything can still talk to kubedns or core DNS. So this is a common policy that you see in a security or platform tier. And that's creating that in there. So you can see for egress, it's allowing either UDP or TCP protocol, port 53. I'm looking for that kubedns label. So now for this last one, well, sort of second to last module in here, just some network policy best practices. So in the very beginning, I mentioned stage network policies. So just as we've written policies here and applied them to our cluster, we would change the kind in here to sort of stage. So it's a staged global network policy, or for the other ones that we had up here, it was a staged network policy. And then we would sort of be able to see the logs in Whisker. We would see them listed under the pending policies. And then we can just check that the policy is being applied to the right traffic, sort of to and from the right pods, before we went and enforced that policy. So it's a kind of a good way to make sure that you've got your selectors written correctly, your protocols, your ports, etc. And I guess while we're here too, I should mention the global network policy. So this policy will then apply cluster-wide. So it's not targeted to a specific namespace, or if we want anything in our cluster to be able to talk to kubedns, core DNS. So we've got this policy just applying globally, and you can see the selector here is just set to all. So basically any sort of pod or any traffic in that cluster will get evaluated by this policy. And I guess we should see that too in Whisker with some of these latest flows if we wait for it to refresh again. Let's see catfacts to the database. Hopefully we would see the global policy because we just applied it in here. In our platform tier. Let's see, allow kubedns, and we can add a filter in here, and then we'd see all of the traffic that this policy was targeting, essentially. And then stage network policy can be useful, so go hand in hand with the default deny, especially when you're first sort of building out your network policies for your cluster. So a default deny policy is something that we recommend. We have a lot of customers doing this. And they might add sort of a global default deny and have it applied cluster-wide. So then you're kind of forced to build network policies, build them correctly so your applications can actually communicate properly. Or some people will choose to have a default deny sort of per namespace and do it that way, just as kind of extra insurance that they're not building a default deny that potentially breaks something that they didn't intend it to. But this sort of changes the behavior then from the sort of Kubernetes default allow all to deny all. So you're forced to write those network policies and sort of allow only the things that you know and trust. So it kind of helps remove the chance of you leaving security gaps by forgetting to block or deny something versus rather than forgetting to allow it. You'll know pretty quickly if you haven't allowed something that you need to. And then again, just a little bit more information about sort of how the network policies apply to different pods and how they get evaluated. So we can actually go and create a sort of very basic default deny policy here. And you'll see actually that we've got the type set to ingress and egress, but we didn't actually write any ingress or egress rules. So because this traffic will now be applying to so all traffic in the Catfax namespace, both ingress and egress, and we didn't write any rules to allow it, all of that traffic will just get denied. So we didn't really need to write a rule to deny it because we didn't write any rules to allow it. And then we can also create a staged policy here as well. So you can see here the kind is staged network policy. And so that policy won't actually be changing any behavior in our cluster, but we should see that policy come up in evaluations. So let's test this out. So we'll go back to sort of the access BusyBox pod, start one of those up again inside here. And now we can try communicating to our Nginx server just like we did in the beginning of the workshop. And we can also try connecting to the fact service as well from within this pod. So let's run a few commands here. So at the moment, no problem accessing Nginx because this default deny policy that we were applying to the quick start namespace is staged at the moment. So we would still expect this to work because we haven't got anything actively enforcing or denying that traffic. And then we can also test access to our Catfax application. And again, that we can see that that one's working. So hopefully now if we go back to Whisker, and we've got our quick start app to the fax. And then we're looking in the pending one here. So you've got that allow Calico network policy. I was hoping maybe in a few refreshes time we'll see that policy appear. But what we're sort of looking for in here, you would see, if I maybe run this a few more times, wait for this to refresh. Source access. We should see the global policy in here somewhere. When I was sort of building this and testing this out yesterday, this is what you would expect to see. So under the pending, because it's a staged network policy, we'd see the name of the policy, so the default deny quick start, the name, namespace, tier, etc. And at the moment it'd be action unspecified. It's not actually sort of doing any actions to the network traffic. It's just showing you that this policy is here and it's applying to those flows. So then we can go in and actually apply a default deny policy that is enforced. Let me exit out of here. And then we can always go and delete, once that would go and delete the staged network policy. So now again, if we go back and go into the access pod for the BusyBox, I guess it's creating a new pod every single time. There we go. And try running these commands again. Wait, copied the wrong one. There we go. So you can see now we've got that default deny policy in place and it's enforced and it's active. We can't access the Nginx endpoint anymore. It's not returning anything because we're now blocking access to anything else basically from that. So if I cancel that one, just do it a few more times, generate some traffic inside Whisker, and then we'll see if we can connect to the Catfax. Oops. And again, it's not connecting to the Catfax either. So our default deny policy is working and is blocking all of that traffic. And then again, we should start to see some more denied flows showing inside Whisker. A few times, there we go. We've got denied flows appearing in here now. And so the next one in sort of network policy best practices is the network steps. So this kind of ties back to the question that we had in the chat earlier, sort of asking about if we would sort of see IP addresses of things that it's connecting to outside of the cluster. So we won't see the actual IP addresses in the Whisker flow logs. You would see that in the commercial editions of Calico. Kind of using the network sets, you can actually give them a meaningful name, which will show up inside Whisker. So the network stat is a way of sort of grouping IP addresses, side ranges, blocks, etc. Or in the commercial edition, so you can include DNS or domain names in there as well. So then any traffic that's going out to these endpoints in the observability, so in like Service Graph in the free tier or on Whisker, you would see the name of the network set. And then also you can reference the network sets within policies. So a lot of people prefer to, if the network policy is referencing something sort of outside of the cluster, an IP address or a domain or something, they prefer to actually just build networks to manage in case those IP addresses change, versus having to go and find policies where they're listed, potentially changing multiple policies. They would rather just manage one resource, which is the network set. Then the policies will reference the network set via its labels. So we can create this network set here. And I guess I need to change the name. Actually, I need to put the right things in here, and let's cancel that. Exit. So we want the IP address of the facts service from the CatFacts namespace. So let me grab that. So the IP address we want is 1096.231.9. So let me copy this again. And then that's 213.231.9. So now we've got a network set. It has the IP address of the fact service. And again, we can go and test access from the BusyBox pod and just run some ping commands to the IP address. So once that's loaded, copy that. And again, we've got that policy in place, that default deny policy. So I'm not really expecting this to work, but what I'm hoping will show is that in Calico Whisker, we'll see that this pod tried to access the sort of CatFacts fact service. That's what we'd see in Whisker, even if it's showing that the traffic is denied. So let's keep going. And I feel like this always works when you're testing it and sort of building the workshop. It never wants to work live. There we go. So we can see here we've got the so the ICMP protocol now, because we're doing a ping test, is going from that access pod, the BusyBox pod, and the quick start namespace to the fact service and the CatFacts. And you can see that the destination name no longer has the like facts pod name, it has the name of the network set. So that's our fact service, which you can see was the name of the network set we created there. So that could be any IP address that you're sort of communicating with from inside the cluster. And then you would be able to get a more useful destination name appearing in here so you knew what that connection actually was, without having to sort of open or do some digging to find out every IP address that it's going to communicate with. So we checked that and that was good. So the last module in here is just showing you Calico Cloud free tier. So if you've got 3.30 running inside your cluster, you can connect it to free tier. You still get access to Whisker sort of locally, but this is an option if you want a little bit more functionality for sort of observability, policies, etc. And the link here for the workshop, it does take you to a little tour, really quick tour of Calico Cloud free tier and sort of what you'd expect from that. So if I can get it to pause here. So as I was talking about Service Graph earlier, or a little bit, Service Graph kind of takes all of the flow logs that Calico is connecting and sort of builds a visualization based upon that. So because the flow logs know where traffic is going from and to, it starts to build a picture. So here you can see, this is an hour here, you can see how they're communicating. You can double click on a namespace in here and it would take you inside, let's say, our CatFacts application, and then we would see a pod for each of the worker, the database, the fact service, etc. And then when you click on each of these sort of flow lines in here, it automatically filters the flow logs like we saw in Whisker, and it gives you some extra insights as well. So you can see that down here. I'm inside my pets namespace. You can see all of the different pods and services that make up this application. And it automatically filters the flow log based on what your all of our pets flow logs visible here. And then again, I guess all the flow logs similar to what we were seeing in Whisker, just in the Calico free tier UI. And there's also a bunch of dashboards for sort of monitoring your clusters. So there's 3, there's cluster health, traffic volume, and flow logs. So again, just sort of more visual representations. There's a screenshot at the bottom when I go back to the sort of workshop in GitHub that shows you would very quickly be able to see all of those denied flows that we were generating today while we were testing out those policies. So if you were just having a quick look at the policy, at the dashboards even, you would see the big blocks of red. You would be able to see very quickly what policy is denying traffic, and then go further into the flow logs, add some filtering in there to go and find out why. And then we've got our policies board. So unlike here on the command line where you're sort of having to run a lot of commands, so you can do kubectl get network, if I can even type, get network policy, and then that gives us some network policies. We might want the Calico network policies. We might want staged network policy, for example. We might want global. So you're basically running, if you want to know what policies are sort of in your cluster, you're running a lot of different commands to, one, get the policies. You don't really know what order they're in. So you would have to go and describe different policies, different tiers, etc. Whereas with the free tier of Calico Cloud, and even the commercial editions too, any policy that is applied in your cluster is visible in the tiers on the policy board. So now it becomes very easy to see, okay, we've got our app cat facts tier, we've got our database facts, and there should be a worker policy in here, I guess, as well. But now just having a look at that very quickly, I can spot that I know I have a worker pod. I can see that there isn't a policy for it. So now I would know and go and create it, where it's via the command line to go and find that information out. And you can't see it on this page either, but you can sort of, this will show and highlight a policy in red if it's denying traffic, or if it's been sort of built incorrectly, it's not actually targeting any endpoints in the cluster. And you can also see which namespace it applies to. It'll show you the volume of traffic coming in and out for each policy as well. So again, kind of like the dashboards, you've got to sort of assess the state of your cluster and whether you're missing policies, whether your policies are denying traffic, or even just finding the policies too if you need to update them. And then we've got our network sets. So just a visualization here of what network set looks like. You can see a list of all the nets here. This is another use for network set that we see people do, is sort of adding in threat feeds or lists of IP addresses that are known to be suspicious or malicious. Or embargoed countries, for example, you can get lists of all the IP addresses associated with specific countries if you want to block traffic to that. And then you would have policies in your security tier that reference these network sets. So then if the IP addresses change that's associated with a country, you can just sort of update the network set separately. You don't have to go in and risk editing your policies. With the free tier for Calico Cloud, you can only connect one cluster, but it does just take a few seconds to get connected. So in a moment, I should be able to do that if I can sign in. And again, like I mentioned, some of the screenshots here. So this was from sort of a cluster setup like this going through the workshop. The denied traffic, you can see it was that quick start, default deny quick start policy that was denying a bunch of the traffic. So we can see big red blob or bar on our chart here, very quickly see which policy it is, and then we would know to go and potentially fix that policy or change that policy if we wanted that traffic to be allowed. And again, service graph 2 will also show you if traffic is being denied. So we've got the quick start to the cat facts. That was traffic that was being denied from that access pod to the fact service. So again, looking in here, we can very quickly see that some traffic was being denied here. If you click on that line, then you get some insights. You can see the volume of denied traffic. You can see what port that was happening over. You can see that it was the quick start side. I don't know if that's very visible, but if you zoom in a lot here, you can see the red pointy bracket thing is next to quick start. So it's being blocked sort of by the source, a policy that's applying to quick start, not a policy that's applying to cat facts. And then again, your flow logs at the bottom will automatically filter where you'd be able to go and find out which policy it was anyway. And you can see here what it looks like if you've got policies that are denying the traffic. You can see the volume there. It becomes very sort of visually easy to spot which policies are denying traffic. And then one thing that's missing from the tour is actually these policy recommendations. So I mentioned that a lot of people, if they're using larger clusters, they might have multiple applications, tenants, etc. in there. To begin with, before they maybe get down to sort of granularity of workload isolation, perhaps they don't need that level of granularity. They might want a network policy that just isolates different tenants, namespaces, etc. So with the Calico Cloud free tier, based on all of the flow logs that it's capturing, it will actually start to automatically recommend you a policy for you that does the namespace isolation. So you can see here, this was after I'd applied a lot of my workload isolation policies in here. So the rule is quite sort of limited. If I hadn't applied those workload isolation policies, I would have more rules listed here, basically. But it learns from all of those flow logs, starts to build up the rules for you. Then you would just click on actions. You would apply that to your policies board. It would start as a staged policy. So you can kind of assess the policy before you enforce it. But it's a much faster way of getting your applications secured inside your cluster fast. So at least putting that boundary in place between applications or namespaces before going in and potentially doing more granular network policies and workload isolation. And again, we've got our network steps. So let me see, I did open a guest Chrome window here. This is where I log in, but if you go to calicocloud.io, you should see a sign up page as well for the Calico Cloud free tier. I should already have an account. If I can remember my password, but probably not. Let's see if I can remember it. I don't think this is going to work, no. But basically in here as well, I think I have a link here, a GIF, showing how easy it is to connect your cluster to Calico Cloud. So once you click on connect to cluster, and you want to connect your first cluster in there, then that will give you, or you give your cluster a name first. And then it will give you this sort of manifest here that you will just copy and paste into your cluster. Literally takes just a few seconds for it to get connected to the Calico Cloud free tier. And then you'll have access to the service graph, to the policies board, policy recommendations, etc. So literally just takes a few seconds, and then you get all the insights and stuff associated with your cluster. But if you're just interested in sort of network policies, building them, Calico Whisker in 3.30 is definitely a big step up from the previous versions of Calico. So now you can sort of write and test your network policies a lot easier. Now you have a way of sort of visualizing all of the traffic, the flows, the labels, supports, protocols, etc. So with that, if anybody has any questions, I think I've answered most of the questions kind of as we're going along. But if there's anything else you can sort of think of as we wrap up now, do write them in the chat. I'll sort of turn my camera off, mute myself in a moment, just hang around in case any more questions do come in. I'll just launch the sort of end of workshop survey, just with a few questions in here, just to get some feedback on the session. As I mentioned, this is our first time sort of building and running this sort of network policy management workshop. So any feedback is definitely very much appreciated. And that should be visible on your screen or in your engagement panel. So yeah, once you filled it in, or if you close it down, I don't know, any questions, pop them in the chat. Otherwise, thanks for joining us today, this morning, this afternoon, wherever you are. And I'll hopefully see you at one of our next events coming up. So have a good rest of your day. I also realized, I don't know if Ravi is still here. In the chat, he was asking whether you can have Calico installed without Whisker. When I was installing Calico, it does point to the Tigera operator in the project Calico GitHub. So if I just paste the link here, hopefully it's still here. It does reference Whisker inside here. So I don't know whether you could just go in the operator and kind of remove the Whisker operator, and then it wouldn't install that resource in your cluster. That would be my guess. Otherwise, I would recommend joining the Project Calico Slack if you haven't already. So I think at the beginning of the README, there is a link to the Calico users Slack group, but I will put that in the chat as well, just in case. So that would probably be the best place to ask. We have our all our Project Calico people, developers, etc., hanging out in there, so they would be the ones to get a definitive answer from. So yeah, if there's any other questions, let me know. Otherwise, I'll sort of close it down in a minute or two.